Biological anthropologists are able to apply engineering principles to the structure of bones in order to better understand the behavior in past humans. Much like the structure of a beam, the structure of a bone determines how well it can stand up to the forces applied to it in life. A principle called Wolff's Law states that bone mass is distributed where it is needed and removed where it is not. Imagine a plastic ruler. When held horizontally, the ruler is easy to bend. When the ruler is held perpendicularly, the distribution of the mass of the ruler prevents bending. The further from the center that mass is distributed, the stronger and more resistant to bending the ruler will be. Now picture a cylindrical long bone, such as a femur. When bone mass is distributed farther from the center of the bone, the more difficult the bone will be to bend. In this example, you can see two different possible cross-sections at the midshaft of the femur. In the cross-section on the right, the femur will be more difficult to bend along the y-axis, which runs anterior to posterior, than in the x-axis. The cross-section on the left will have equal resistance to bending in the x and y axes. Biological anthropologists can measure the strength of bone by measuring the distribution of bone in different axes of a cross-section to determine how strong and resistant to bending it will be. This information allows us to make hypotheses about the types of physical activity humans in the past performed. For instance, long-distance running places greater bending stress in the y-axis. By comparing the cross-sections of bones from different groups, anthropologists can better understand the variation in physical activity in the past. Hunter-gatherer groups tended to have greater bone strength than agriculturalists, suggesting that the physical activities of hunter-gatherers was probably more rigorous.